Okay, everybody, so we're going to continue with the fractions today. So last time we saw how to add unlike fractions. So we talked about the least common denominator that we need before adding or subtracting fractions. Today we're going to continue with addition and subtraction, but this time with mixed numbers and fractions together, and even whole numbers. So we'll see how to add and subtract those. So the first example, or this example here. Okay, so last time again, we learned that before adding or subtracting fractions, you must have the same denominator. If you don't, you need to find a common multiple or a common denominator like we did last time. If the denominator is the same, you keep it the same and you add or subtract the numerators. In this case, 1 and 2. Which is 3 over 3, that's 1. Same with subtraction. For example, 5 over 7 minus 3 over 7. Make sure you have the same denominator. If you do, just subtract the tops, so you get 2 over 7. So now we're going to see what happens if you have mixed numbers here, along with fractions. So let's say you have 2 and 1/3 plus maybe 5 over 3. So you can see here we have two different types of numbers. This is a mixed number. This is here is a fraction. Okay, so what do you think we need to do first here in order to add these two numbers? I'm sorry, I can't hear you. Can you get closer to the microphone a little bit? Speak up.
2 multiplied by 3 is 6 plus 1, 7.
So that's right. We need to turn this into a fraction. This one is already a fraction. We're going to turn the mixed number into a fraction. So we're going to times these two. 2 times 3, 6 plus 1, 7 over
3.
Same denominator, that's right, 5 over 3. And luckily here we have the same denominator, so it's going to stay the same. And I'm just going to add these two. So that's 7 plus 5, which is 12 over 3. And always simplify your fractions or your answers to the lowest terms. You can reduce this into 4. Okay, so whenever you see mixed numbers, just like we did with multiplication and division before, always turn them into fractions. Once you turn them into fractions, see if you have the same denominator. If you do, that's fine. If you don't, then you need to find a common denominator. For example, let's say you have 1 and 1/4. Let's try to add this to another fraction, maybe 2 and maybe 1/3. Okay, so we have two different fractions here. I mean, mixed numbers. So obviously, we don't have fractions yet, so we need to make these fractions. There's two ways you can do this. You can add the whole numbers together, 1 and 2, and then add the fractions together. Or you can turn both into fractions like we did here. Once we turn them into fractions, then we find a common denominator. For example, here we can say, so again, convert times these two. 1 times 4 plus 1, that's 5. Over 4, and over here, we're going to do the same thing. 2 times 3 plus 1, 7 over 3. Now at this point, we have different denominators, so we can't add right away. We need to find, what do we find here?
Huh?
What do we need to find here? So we can't add these two right away.
The lowest common denominator.
That's right. So we need the common denominator for 4 and 3, which is?
12.
12. That's right. So the common denominator here is 12. So LCD We talked in detail about how to find the common denominator. Just refer back to the previous lecture.
That quiz is frustrating me, mister, because I know I didn't have time. I really didn't prepare, and there's no way that I should have gotten that grade.
Okay, we'll talk about the quiz later. So once you find the common denominator here, what do?
You add 5 and 7 is 12.
No, we don't
Yes.
add the 5. We don't add 5 and 7 yet. We need to do something else. So we're going to change this into this. So we times this by 3. You got to times this one also by 3. You can't just add them right away. We need to multiply both by 3 in order to turn this into an equivalent fraction. Same way here, to turn 3 into 12, we're going to times it by 4. We're going to times this by 4. So we've got 15 here. And we have 28. Okay, and now that we have the same denominator, we keep it, and we gotta add these two. 15 and 28, which is 43. And since we started here with mixed numbers, we're gonna see if we can turn this into a mixed number. This is an improper fraction. First, you gotta try to reduce it if possible. Nothing goes into 12 and 14 and 12.
Okay.
But we can turn this into a mixed number.
Green.
That's right, 12 into 43, that's 3 times. The same denominator here, 12 into 43, 3 times. What's the remainder?
I think it's 9.
Is it 9? Not exactly 9. So we have 12 into 43.
4 12s are 48.
So
48, 5, 3.
3 times 12, that's 36. So we're going to see how much is left from 43 so that you can go here. So you can always do subtraction. So turn it into 3, 7, and 0. So you have 3 and 7 12s. Okay, so especially if you start with mixed numbers, your answer must be a mixed number if you end up with an improper fraction. Okay, and that's pretty much the sum of the two fractions. It works the same way if you have a subtraction here, the same way to convert, find the LCD. Only difference is instead of adding here at the end, you subtract.
Huh? Subtract what?
We subtract instead. If you have subtraction here, we subtract instead of adding. Okay, so now let's look at an example of subtraction. So let's say maybe and take a number here, 5. From that, we want to subtract maybe 3 and 2/5, or maybe just 1/5, 1 and 2/5 instead. So now we have two different types of numbers here. We have a whole number, subtract, and a mixed number. So they gotta be the same. We're gonna try to make them the same before we can subtract them. So we're gonna turn both into fractions. How do you turn the first one into a fraction?
You put it over 10.
That's right. So over 10, you said?
Yeah.
Why over 10?
Why over 10? Because it's on the 1 over 5 is only it only has one digit.
No, to turn a whole number into a fraction, you just put it over 1. Because 5 divided by 1 is the same as 5. Okay, just 1, not 10. Minus this one, we're gonna convert it the same way we did here. It's a mixed number.
Sorry, Professor. Sorry. So if this is 5, take away 1 over, let's say 20, you would still turn the 5 into a fraction over 1?
That's right. Yeah. Any whole number can be simply put like this. Because dividing a number by 1 doesn't change it, but we can turn it into a fraction like this.
Okay, and if you put it or if you put it over 10, that's changing the number.
That's changing the number completely.
Okay. Okay.
So here we have mixed number. So again, 5 times 1 plus 1, that's 6 over 5. Now that's good. We have fractions, same type of number, but we don't have the same denominator here. We need to find one. What's the LCD here? 4, 1,
5.
and 5.
5.
That's right. LCD is 5. And we're going to turn these into new fractions, both with 5, both with the LCD, so we can add them. So this, to turn this into 5, we're going to multiply by
Huh?
5. Also here by 5. So 1 times 5 is 5. 5 times 5 will be 25. This one, 5 goes into 5 once. So it's not changing anything. 5 times 1 is 5. 6 times 1 will be 6. So 25 and 6. And again, we discussed this in detail in the previous lecture, how to find the LCD, how to multiply this to turn them into the same fraction with the same denominator. Okay, again, once we have the same denominator, it stays the same, subtract these, so 25 minus 6 will be,
That's be 19.
that's right, 19 over same denominator. Again, always try to simplify first before converting it into something else. Nothing goes into 19 and 5.
3.
It's an improper fraction, that's right. We can turn it into a mixed number. So 3 into 19. I mean, 5 into
3 times. 3, 5,
right, 3 times.
The 4 remaining.
And 4 is the remainder, and you'll bring the same here. And again, we talked about how to convert this 2 or 3 classes ago, how to convert back and forth between mixed numbers and improper fraction. And that's the answer there. Okay, so it's pretty much the same as before. We need the LCD, but before that, if you have fractions or mixed numbers or whole numbers, we need to convert them into fractions first. Any questions so far, everybody?
Is this on lecture for us to watch, Professor?
What do you mean by that?
What we're doing right now, is it up for lecture? I'm asking because I'm not sure if I'm going to be able to stay the whole session today. So I'm just asking.
What do you mean? You mean if it's being recorded?
Yes, thank you.
Yeah, it's being recorded. I'll post this sometime later.
Okay.
Everybody else, are you okay? Alvaro, Brianna, Jennifer, and Pierre. Are you guys all right? Any questions?
No, I'm okay.
Okay, again, this is the third class or so on fractions. We started this talking about mixed numbers before and addition, subtraction, and multiplication, division. Then we just continuing on that. You may want to watch the previous ones so this can make more sense. So let's look at another example here of adding some mixed numbers and fractions. Okay, so sometimes it can be convenient if you have, let's say, 1/2 and 4 and 1/2.
7 1/2 or 1 1/2?
7 1/2 minus 4 and 1/2. If you have something like this, if you notice that you have the same fraction, could possibly be easier to just, let me put some number here, for example, 3. I mean, let me change it up a little bit. So So let's say you have sometimes it can be convenient to do this in a different way without having to turn them into fractions first, especially if you have the same denominator here in the fraction part of the mixed number. We can basically subtract the whole numbers together. We can do 7 minus 4, which is 3. And since we have the same denominator here, we can also go ahead and subtract right away. So we can do 3 minus 2, which is 1, and the denominator stays the same. It's probably faster and easier instead of doing all this, converting into fractions first. So that works both with addition and subtraction. So if you have the same letter fraction here with the same denominator, believe you don't need to turn into the mixed numbers into fractions first, as we did here. You can do this faster with addition or with subtraction. Let's do another one this time, maybe with addition. Let's say you have 2 1/3 plus, let's say, 4 1/3. What would this be equal to right away without having to do all these steps?
That would be 6 and 2/3.
That's right. So we can add the whole numbers together. That's 6. And the fraction part would be 1/3 plus 1/3. So 1 plus 1, that's 2. The denominator is the same, so we don't need to find a common denominator. You can just say 6 and 2/3. So take advantage of that. That can be quick and easy. And otherwise, if it's not the same here, you can convert first into fractions and find the LCD. So this is like a shortcut that can be helpful sometimes. Let's see another example. Okay, now let's see if you have multiple numbers, not just 2, maybe 3 or 4. So just like the order of operations, if you have multiple fractions, or multiple numbers, we can always use the order of operations to simplify them. So let's say you have 2 1/3 plus maybe 4 and some fraction here, 1/6, for example. You have 3 numbers, they're all different. So what do you think we do first? We want to add all these 2 together, all these 3 together. What do we do first?
4 into a fraction.
That's right, we're going to turn all into fractions. We're going to turn all into fractions. This one is already a fraction. This, we're going to put a 1 here. This mixed number can be turned into an improper fraction. So we can end up with...
So that's 7/3.
That's right, 7/3 plus...
4/1.
That's right, 4/1 plus... 1/6. All fractions now. So we can add all of them together at the same time. You can add all of them together. You don't need to find the LCD for 3, 1, and 6. What's the LCD here?
6.
That's right, 3, 1, 6, all go into 6. So now we're going to turn all these into new fractions with the same denominator, 6 here and here. But we need to do something here. So to turn 3 into 6, we multiply it by
6.
Nope.
Well, you said to turn 3 into 6. Sorry, multiply by 2.
That's right. We're going to times it by 2, also by 2 here. And 1. To turn 1 into 6, we're going to times it by.
I'm following you, but I'm something I was a little distracted when you were doing something in the other problem. So
Okay, let's just finish this problem now. So 1 goes into 6. How many times?
6.
6 times. And also, whenever we multiply here by a number, we need to multiply the top by the same thing. 6 and 6, 2 and 2. Finally, 6 goes into 6.
1 time.
1 time. So we're going to times by 1 by 1. So now we turned, we're going to turn this into new fractions here. 7 times 2 is 14. 6 times 4, 24. And of course, 1 times 1 is 1. And finally, now that we have the same denominator, we can add all of them at the same time. So the denominator stays the same, and we can add all the numerators together. So 14 plus 24 plus 1. And so I'm going to add these two first. That's
4 and 4 is
38.
8. That's 38, 39.
38 and 1 over, of course, 6. At this point here, again, always reduce. Can we reduce this fraction?
6 and 3 over 6.
Is that again? So we have 39.
6 and 3 over 6.
So what number goes into both of the numbers?
6. Huh? What number goes into both of them? I just divided 6 into 39.
And what's 6 into 39?
6 with 3 remaining.
Okay. So we're going to say 6 times, same denominator. 6 times 6 is 36, so we have 3 left from here. And as you can see here, we can reduce this letter fraction here by 3. So this will be 6.5. Because 3, cancel 3 and 3 from both, you get 6.5. Or you can simplify here first before converting. Either way, you get the same result. So that's what happens when you have multiple numbers, different numbers. You can turn both of them or all of them into fractions, or you can do 2 at a time. You may want to probably do left to right. You can maybe do this addition first, finish it, and then bring the other number down, especially if you have addition and subtraction, for example. Let's say we have 2 over 9, and maybe, actually, let's make it bigger than that. So you have this minus 1/6 plus okay, so we mixed up some additions and subtractions here. So again, we're going to follow the order of operations. When you have addition and subtraction addition together, which one do you do first, or in what order do you do that?
Right to left.
You mean left to
Sorry,
right?
left to right.
Then the left to right. So you can still do the same way as here, or you can do the subtraction first, finish it up, and then do the addition. So let's start with this part here. I'm going to do the subtraction. Obviously here, we can't subtract because we don't have the same denominator. But we can, we need to find the LCD for 9 and 6. What's the LCD for 9 and 6?
18.
18 is great. Yeah, we can use 18. So we're going to turn both into new fractions with 18. We need to change this accordingly. So 9 into 18 will be
2 times.
2 times, and also here by 2. And 6 into 18.
3 times.
That's right. And 3 times here. Again, we're going to finish this one first and later bring this one down. Or you can do it the same way as here. Turn all into fractions first, find the LCD for all, and subtract. So this turns into 10 here. 3 plus, and let's turn this one into a fraction now. And we're going to continue with the subtraction. So we have 3 here. 1 times 3 plus 2, that's 5. Let's finish this one first. So the common denominator is 18. 10 take away 3, that's 7 plus 5 over 3. Okay, so now we're down to the addition. So same thing. We're going to add these two, but we need to find the common denominator. We can't add right away. I've seen people do this. It's wrong to just add fractions right away. You have to have the same number here. In this case, what is the LCD of 18 and 3?
18.
That's right, 18. So we're going to turn these into 2. So this basically is like times it by 1. Will stay the same. And here, 3 into 18. How many times is that? Right, 6. And here?
6.
Also 6.
30.
Right? So 7 here. 7 times 1 and 30. Finally, now that we have the same denominator, we can put 18 here. Add these two. 37. Okay, what is the last thing you want to do now?
Simplify. 2 and 1 over 8.
Right, first we try to reduce it if possible. I don't think there's anything that goes into 37 and 18, but it's an improper fraction. You can turn that into a mixed number. That's right, 18 into 37, that's twice. That's twice, which is 36. So twice and 18 here. And of course, the remainder is from 37 will be
1.
1. Okay, 2 and 1 18th. That's pretty much how you add any sorts of numbers related to fractions, either fractions themselves, mixed numbers, or whole numbers. Works the same way every time. You need the LCD if you don't have it. And always convert your mixed numbers and whole numbers into fractions first, then find the LCD, or if the fraction parts have a common denominator, then it's probably convenient to just subtract the whole numbers or add them. 7 minus 3, 7 minus 4 is 3, and subtract these right away. So you don't have to go through extra 2 or 3 steps. Same thing here. If you already have the same denominator here, that's convenient. You can just add the whole numbers together and also add the fractions together right away. In the next class, we're going to see how to mix everything up. I think we already did it before, but we're going to mix addition, subtraction, multiplication, and division of fractions. Mix them all together in one and use the order of operations to simplify. Much like this, but we're going to add addition and division and multiplication to this. And that would be our last class on fractions. So we've spent about 3 or 4 classes on them so far. Okay, so we're gonna do that next class, along with any questions about fractions. If you have any questions on fractions in the next class, let me know. Make sure you review the previous 3 lectures or so in addition to this one. We're going to try to review all of them in the next class. Any questions at this point, everybody? Before I give you some practice problems to work on. Any questions, please let me know.
Can you scroll down page for a second, Professor?
Like this?
Yeah, so I can see, scroll down a little more.
Mm-hmm.
I have to watch the lecture.
Okay, so this whole thing will be posted, either this one or something similar. All right, so let me give you some practice problems now to do on your own. Give you some time to work on them. So, add or subtract. Okay, so that's your practice. A few problems here, just like we've been doing. So take give you some time, 10, 15 minutes or so to work on them. We'll work on this together once you finish.